Okay, so now it is recording. So let's get through our administrative stuff here. Is there anybody in here that has not used Blackboard? Blackboard, show of hands. So everybody's been in Blackboard. That's good. That helps out. Now for this class, you are not required to use Blackboard. There's just a lot of stuff out there that makes life easier if you do. So if you go into Blackboard, the first little announcement here is just a little introduction. Most of your useful information, your grades will be out there if you click on My Grades. Right now, of course, there are no grades out there. You can see the 5 tests are in there. Most of the useful information will be under Course Information. You'll see my contact information is there. We'll go over that again in a second on the syllabus. Both WITC phone numbers are there, and that's my voicemail extension. I'll warn you, I will never answer my phone because I'm never in my office. I go there for literally like 30 seconds a day to see if I have any mail, and that's about it. Otherwise, I do get a notice if there's a voicemail. It actually gets sent to me in the classroom here, so I do know if there's a voicemail, so I know to go up and check it. Easiest way to get a hold of me is through email. I check email a couple of times a day. So if you need anything or if you just need to notify me of something, I'll get it pretty quickly that way. Okay, I'm going to come back to the syllabus in just a second. My schedule is posted down here. That just shows when I'm available and when I'm in class. For those of you in New Richmond, most likely you're going to be contacting me through email anyway. But if you can see that on Fridays here, I am available both right before and right after this class. So if you need to talk to me, you can let me know and I can try to set up, get the session to either stay up late after class or to come up early so that we can, if you have some questions or need to talk to me, we can do it that way too. If you're in Rice Lake and you're looking for me, look for me in this classroom. It's where I spend most of my day. Next out here is an assignment schedule. I didn't put dates on it, I just put weeks on it. This class ends up being only 15 weeks. You can see week 16 is an extra week allowed for makeup or cancellation or whatever. The reason that happens is when we teach this in the spring, we lose Good Friday. So we do only get 15 weeks. So the 15-week schedule is pretty much on. So you can see here, the beginning of week 3 is our first exam. So that is 2 weeks from today. In the first hour of class will be our first test. So that one comes up pretty quickly. And then it just lists off the pages and problems out of the book that'll be homework that I'm hoping that we get to for the week. So if I get to the end of the class and the network cuts out or whatever before I can give the homework, you can always look at the schedule and do the next block worth of homework. Any questions so far? Okay. The next thing out here, these are the solutions to the homework problems in the book. So if you're going through the homework, feel free to look at these and check your answers. In fact, I prefer that you check your answers. I'd rather have you do a couple of them and check your answers and make sure you're doing them right than have you do a whole assignment and then realize later you did them wrong. Because now you've developed a bad habit and you've got to unlearn that before you can learn the right way to do it. So those are all out there for you to double check your work as you're doing it. Another thing that's going to be out here, there isn't anything now, is the links to the videos will end up being down here at the bottom of this page. And I'll show you that here in just a second. I'm going to open the syllabus so that I have that. And then I'm going to go to last semester's class. So we'll come back to the syllabus in a second. I'll show you what those videos look like just so you're not surprised by anything. Oops. So this is last semester's class. So you can see all the same stuff there. Then we've got all these videos down here. Those links, they are hyperlinked. If you click them, they sometimes work. Sometimes they don't, depending on what browser you're using in Blackboard. I find it's usually easiest to just copy the link and paste it into your browser. They always work if you do it that way. And you can see, I suppose YouTube is going to make us do a commercial here. They got to pay their bills too. So, and there it is. You can see my smiling face on the webcam and what is appearing on the computer screen. Come on. And so that's all it is. I have my sound turned off so you can't hear the voice right now, but that's all it is basically, is just what's up on the screen in front of you. Feel free to use them however you want to. I have a lot of students who have said, I know I do tend to talk fast sometimes, so I've had a lot of students say they can't keep up taking notes, so they'll stop taking notes and come back later and fill them in off the videos. If you want to put them up on the big screen and invite some friends over and pop some popcorn, I don't care. However you want to use them is up to you. If you charge admission, I get half of the gate. Yeah. Just kidding. Well, not really. If you charge admission, I do expect a cut. We'll see how that works for you. Okay. So to the syllabus. There's all my contact information again. If you're looking for me, if you're on campus here and you're looking for me, I'm in room 162. You can find me there. You guys are here, so you know when and where the class is. I don't need to go over that. Our description, this is math for healthcare fields. We go over some basics to get you up to what some of the things that, to make sure you know the background that you're going to need for the medical style math. Then as far as the medical part is concerned, we do a lot of measurement conversions. Then we do the dosage calculations, which are the big important part of the course. And we take 3 to 4 weeks on those. And then at the end of the course, we do some prep for what's going to happen next for you. If you're in the nursing program, most of you are going to end up going on to a 4-year degree now. That requirement is going through that you need a bachelor's degree for nursing in most cases. So there's a little bit of algebra, a short 2-week unit on algebra, because if you were to go on from here in a bachelor's degree, you'd have to have a college algebra course. And then another short 1-week unit on statistics, because any medical field that you would go on to a bachelor's degree in would require a statistics course. So we obviously can't do enough to fully prep you for it, but give you a little bit of an introduction so that if you go on, you've got a little bit of a background to get you started. Okay, textbook. Looking around the room, it looks like most of you have this one. I don't know how well you can see it on the network, but it is the Mathematics for the Health Sciences. It's Joel R. Helms. Is there anybody that does not have their textbook? Looks like we're pretty good that way. Okay, good. We're off to a good start here. Other things that are recommended, a calculator is highly recommended. Not required. I allow you to use your cell phones, but I know most of the programs will not allow you to use your cell phones as a calculator on tests. If you don't have a calculator and you're looking to buy one, the one that I usually recommend to people is a Texas Instruments. It's a TI-30. And I recommend that one because it does fractions very well. And it does anything you could ever possibly want to do in this school with, any program you went into, it does all the trig and stuff like that. You don't need trig for the medical fields here, but that has it all on there. Any of you that might want to, or considering double majoring, like a business degree where you'd have to do the business math class, you'd want to make sure you get the TI-30 with the Roman numeral 2. That's the 2-line display, because there are some longer formulas in some of those classes that the basic one struggles with a little bit. If you have, most likely if you have any sort of calculator, it's good enough to get you through the course. If you're not sure, let me know and I'd be happy to take a look at it for you. If you have a graphing calculator, if you had to have one in high school, or if you had kids that had to have one in high school and you're using theirs, that is fine as well. The graphing calculator does not do fractions well, is the only drawback to them. But you are welcome to use them if you want to. For this class, by the way, you will be allowed to use your notes and your books on everything. You'll be allowed to use your calculators on almost everything. Your first unit test, you will not be allowed to use your calculator on the first half of it. Now you can, after you've done it, go back and check the answers with your calculator, but you must show your work to get credit on that first half of the first test. So you have to show that you did the calculations by hand. So here's our competencies again. We have the fractions, decimals, in other words, basic arithmetic for some review. We have percents. Then we're going to have conversions between percents, fractions, decimals, ratio problems, our measurement conversions, the big dosage calculations for medical math, the algebra I mentioned, the equations, solving equations and graphing equations, and then the basic statistics. Okay, grading information, which I'm sure is one of the biggest things you're concerned about. For this course, because of the nature of the course, being for our medical fields, we kind of try to follow their example a little bit more, and being offered in multiple locations. I mean, I almost never teach this class just at one location. It's almost always over the network like this. Because of that, your grade in this class is based completely on the average of 5-unit tests. So the homework out there is listed. That homework is for your practice. I will never collect it and grade it. That doesn't mean don't do it, because that's how you can practice it and make sure that you know how to do the problems and that you understand the material. But your grade is completely based off of those 5-unit tests. Now, that's not as scary as it sounds. Once you've done a test, once you've completed a test and I've graded it, I will return it to you, and any problems you got wrong, you will be able to redo and resubmit it, and you can get up to half your points back. So let's say you do the test and you struggle with it a little bit and you get a 70% on it. I hand it back, you redo the problems you got wrong, hand it back in, that can get you back up to 85%. With that said, when you go to redo them, anything goes there. I mean, you can sit down with a friend in the class and work through them together. You can come to me and I will sit down and work through them with you. Make sure that you have them done correctly before you turn them back in. When you redo them, I do require that you show your work so that I know you're not just finding a friend that got it right and copying down the answer. My main purpose for doing that is I want to make sure that before you leave here, you have the right process written down and you have seen at least the correct way to do it. Okay, so then we have the standard WITC grading scale here. I'm sure you've seen that a couple of times. Withdrawals and dropping. Just a very quick note here. There are deadlines in the student handbook for dropping and refunds and stuff like that. I'm not going to try to go through those. But if you do, for some reason, need to drop this class or withdraw from school, don't just disappear on us. And actually, a couple things. One, don't just stop coming to class. If you're not going to come to class anymore, do take care of it, get it dropped or withdraw from it, or what do you need to do. But also don't do it without talking to someone. Whether you're talking to me or a counselor, make sure you talk to someone first so that you know what all the possible consequences are. Sometimes there's issues with financial aid and other things if you drop a class that might not be easily foreseen. Okay, college policies. Basically, don't cheat, don't steal, don't do stuff with school equipment that you're not supposed to. I don't think I need to go through that too much. Accommodations. If you have any needs, whether it's a diagnosed disability or whether maybe you've just always struggled at math and you're nervous about taking the course or whatever, come and talk to me. I mean, we can set up private rooms. We can set up extended time for you. Whether you have accommodations or not, I usually do allow, I always allow unlimited time on your tests. So if you need more time outside of the time we've set aside in class, just let me know and we will get that set up for you. And anything else you need, whether something I'm doing in class that's making it hard for you to learn or whatever, let me know and we'll do what we can to try to make things better for you. And then again, just the notice about the videos being posted. They are posted publicly, so they are out there for the world to see. So again, don't do anything that would make it on the video that you don't want other people to see. Then the schedules in Blackboard, I showed you that assignment schedule, so I didn't put one on the syllabus again. Any questions?
How is New Richmond taking their tests for you?
I will send those to New Richmond, and one of the ITV facilitators will have them. And usually one of two things will happen. Either they will bring them into the room in a folder, and they'll be sitting in a folder up by the ITV unit. Or they'll just bring them in at the beginning of class and pass them out for you. Then once you're done with those, usually what I have students do is you just put them back in that folder. And then the last student to leave the room, take that folder to the ITV office so that they remember to send it to me. I have had classes in the past where everybody just put it in the folder and left the room, and the ITV office forgot to come pick it up. So I've had to, 3 or 4 days later, I've had to send them an email, hey, could you go try to find this for me and get it to me? So yeah, it's all handled right there. They will be right there for you. They'll be right in the classroom you're in. Thank you. You're welcome. Any other questions? Okay. I'm guessing you are Allison? Yep. Okay. Yep. Perfect. That officially means I've had everybody show up for the semester so far. Cool. Usually I have at least 2 or 3 that I never even meet. Okay, so we're done with Blackboard. Let's take a look at some material. I should apologize. I do realize my voice is pretty rough today. Just my luck, I catch a cold and lose my voice last Sunday, the day before classes start. So hopefully you guys can hear me okay. So anyway, I want to go through some preliminary stuff here in the first hour, and then we'll take a break at the end of the first hour here. As you saw when we were looking through the syllabus, the topics for the course, there are some very basic topics that we start out with in here, and there's a reason for that, a couple of reasons for it actually. One is some students have been out of school for a while and need a little bit of review to get back into it. Second is, through the years, I've found that a lot of the struggles and misunderstandings students have with the more advanced topics come from not totally understanding the most basic topics. And if we take the time to go back and understand those basic topics, once we get to the more advanced stuff, things fall into place a little easier. Now, in this course, we don't have a lot of time for the basics, so we do fly through it pretty quick. But I do want to give you just kind of a basic picture of stuff. One of the topics that students tend to misunderstand, or don't fully understand, I should say, and probably the most basic, and now by basic I don't necessarily mean easy. By basic I mean the topic that most things in math are based off of, is the concept of what is a number. If I put a 4 up here, with a show of hands, how many of you would tell me that's a number? Most people would, right? Some of you are like thinking there's something up right now. 4 is just a numeral. It is an amount. It's telling us how much. To truly be a number, we must be told 4 of what? Like 4 cows. So now we're being told how many. That's the 4. I'm going to call that a count. But we're also being told of what? What it is we have 4 of. In this case, it's cows. I'm going to refer to that as the name. So to truly be a number, it must have 2 parts, a count and a name. Now I realize you're thinking, oh no, here's another one of those mean math teachers who's going to make us label everything or he's going to mark it wrong. And normally that's not my style. But being medical math, labels are very important. I mean, is it milliliters or microliters? So yes, in this class, you will have to make sure you put the units on your answer. Unless the units are given in the answer blank, you will have to make sure you do that, because You can't just write down on a medical chart 13. You know, is that 13 liters or milliliters? Is that 13 milligrams? What is that standing for? But the main reason I bring up those two parts of a number here is because if you look at those two parts and analyze how they work in our most basic math operations, it explains a lot of the other rules we've been taught. For example, let's look at our two most basic math operations, addition and multiplication. Now, some of you might be wondering, well, where's subtraction and maybe even division? Well, subtraction really isn't its own operation. Subtraction is part of addition. Before the end of the day, we'll actually take a little bit of time to look at that. One definition of subtraction is just addition done in reverse. And we'll look at a couple of those working definitions of subtraction. So because of that, anything that I say, any rules I put out here for addition also apply to subtraction. The same goes with multiplication and division. Division is not its own operation. It's just part of multiplication. So now let's do a simple addition here. Let's say we have, let's do 3 inches plus 6 inches. What do we get? 9 inches. Very good. Hopefully nothing real profound yet. Probably not quite worth your $300 for the course yet, right? But let's take a look at what happens with the count and the name. So here we have counts of 3 and 6. Those get combined to make 9. So we're adding here, so we're going to combine the counts with addition. So with the names, you have inches, and it becomes, well, inches. It just stays inches. So the name stays the same. We keep the same name. Now that probably seems pretty obvious so far. But what isn't as obvious is what happens with our multiplication. Let's have 3 inches times 6 inches. First of all, is everybody familiar with the dot used for multiplication instead of the x? Okay. Means the same thing. So we multiply 3 inches times 6 inches. What do we get? 18? Bless you. 18 what?
Inches.
Not inches, but
No.
inches squared. If you think about it, if we're multiplying 3 inches by 6 inches, chances are we're looking at an area of some sort where we're multiplying, we're going to get inches squared or square inches. So if we look at what happened here with our count and our name, we still have counts of 3 and 6. It became 18. So we combine the counts to get 18. This time, since we're multiplying, we combine the counts with multiplication. The difference comes in the names. We had inches and inches, and it became square inches or inches squared. When we multiply, we also combine the names. Now that seems like a very, very subtle difference to point out, but it's actually huge. Like I said, all of those other little rules we've learned for our other forms of numbers come from that difference between addition and multiplication. In fact, it even tells us, it limits what we can use in each operation. For example, let's go back to my cows here. Let's say I take 4 cows plus 2 boys. Do I get 6 cowboys?
No.
That doesn't work, does it? Or since we're going down that path, let's try it the other way. If I have 2 boys plus 4 cows, do I get 6 boy cows?
No.
Obviously not, right? Anybody with a farming background in here? A few of you? You can tell me that that's a whole bunch of bull, right? Okay, it's a long way to go for a joke, but there's a point behind it. I couldn't add 4 cows to 2 boys because when I add, I'm going to keep the same name. That implies that I must start with the same name. If the names aren't the same, which one do I keep? On a little bit more practical example here, I might try to add 5 feet plus 2 pounds. When I try to add those, I get 5 feet and 2 pounds. They have different names. I cannot add those. But for multiplication, if I did 5 feet times 2 pounds, because I am just going to combine the counts, so 5 and 2, 5 times 2 is 10. And then I'm going to also combine the names, feet times pounds is foot-pounds. So when I multiply or divide, I do not have to have the same name. Now again, that might seem like a very small point, but as we go through our other types of numbers, everything we do with those types of numbers comes off of, all those little rules we were taught, comes from this. Now you might be thinking, how does this apply to the larger numbers that we use all the time? Well, there's another concept that bridges that gap. Another one of those basic concepts that most people are never taught the real significance of is place value. If I start at the end of the number and work my way backwards, this last digit is what place value? Ones, very good. The next one? Tens, and then hundreds. And those are actually our only 3 place values. They get repeated over and over again. So ones, tens, hundreds. Ones, tens, hundreds, and over again. This here is what we call our base group. This next set of 3 is the thousands, and then the millions, and then the billions, and then the trillions, and so on. I'm not going to go over how to pronounce a number or anything like that with you. I'm not going to go over, well, I might take a quick look at like rounding, but when we put a number in here, like 7,284, that representation that we're used to seeing, 7284, we know what it stands for just by the position of the digits. But that's really an abbreviation. The full form of that number, sometimes called the expanded form in some books, is 7 thousands or 7 1,000s, if you want to pronounce it that way, and 200s, and 8 tens, and 4 ones. Written out like that, our operations, the long operations we do, make a lot more sense. For example, let's say I have 364 plus 425. If I write those out in that full form, so 300, 6 tens, and 4 ones, and then this will be 400s, 2 tens, and 5 ones. With the numbers written out in this full form, it's easy to see, or it's easier to see, that each digit actually is a count and a name. This isn't just a 6, it's 6 tens. Now, we have always been told that when we add or subtract numbers, we have to line up the columns, right? Well, the reason for that is when we add or subtract, we can only combine things that have the same name. That comes right down to the place values, right down to the individual digits. I can only combine ones with ones and tens with tens and hundreds with hundreds. Lining up those columns is doing that for us. And then, of course, we can add the columns. 4 and 5 make 9, 2 and 6 make 8, 3 and 4 make 7, so 789. I'm not going to go over the process of long addition because I'm assuming you guys can handle it. If you have any questions on it, let me know and we can go over it more next week when we get to it. So subtraction, again, same way. You have to line up those columns because we're only going to be able to combine things that have the same place value, same name. So when we do multiplication, like we might have 213 times 32. So again, let's write them out in long form. 200s and 110 and 3 ones, 3 tens and 2 ones. When we multiply, we do not need the same name. So what that means is this 3 tens here not only can combine with that 110, can also combine with the ones and the hundreds. In fact, every digit in the first number can combine with every digit in the second number. And long multiplication is nothing more than an organized process of making sure that every digit in one number gets combined with every digit in the other number. So depending on what region you're from, you might start in a different spot. Around here, we've always been taught you start with the bottom number and the last digit. So we're going to take that times the last digit of the first number. Still, we're going to combine counts and the names. 2 times 3 is 6. Ones times ones is ones. 2 ones times 1 tens. 2 times 1 is 2. Ones times tens is tens. 2 ones times 2 hundreds. 2 times 2 is 4. Ones times hundreds is hundreds. So now we've multiplied, we've combined that digit with every digit in the top number. I'm going to move over to the next digit. What have we been taught to do down here before we can move over to this digit? Put in a 0 or leave a blank or whatever, right? The reason for that will become apparent here in this next step. So we've got 3 tens times 3 ones. 3 times 3 is 9. Tens times ones is tens. Putting in that 0 is just making sure our place values stay lined up with the same place values. 3 tens times 110. 3 times 1 is 3. Tens times tens, hundreds. And then 3 tens times 2 hundreds. 3 times 2, 6. Tens times hundreds is thousands. So I've got 6. 9 and 2 is 11, so I'm going to keep the 1 and carry the 1. 1 and 4 is 5, plus 3 is 8, and 6. So 6,816 we get. Now I realize that after this first test, after you get through the part where you're not supposed to use the calculator for, after that you're going to use the calculator for these. I do hope, or at least I recommend, that you look at this and say, okay, that's about 200, this is about 30. 2 times 3 is 6. Hundreds times tens is thousands. I'm expecting an answer about 6,000. So when your calculator spits out 6,816, you at least know that it's not a ridiculous answer. Okay. I do want to take just a second to go over long division. And I want to show you a little bit more time on it, and I want to show you a little bit more background with it. Because long division is the one operation that we've taken a bunch of shortcuts to the point where we don't even really recognize what it is anymore. We've all been taught this process of long division, and we do it, but we really don't know why we're doing it that way. Basically, our reasoning is because somebody told us to way back when, right? So let's explore the division just a little bit. First of all, since we said division is part of multiplication, I'll take just a little peek back at multiplication. If you think back to like first grade or so, when you started multiplying, before you memorized your multiplication tables, before you just knew that 5 times 3 was 15, how did you figure that out?
Added 5 3 times.
There you go. We added 5 3 times. We added 3 5s together. Gave us 15. Multiplication is defined to be repeated addition. So we can take that number 5 and add 3 of them together. Well, we said that division follows the same rules as multiplication, just in reverse. So 24 divided by 8 is not repeated addition, it's repeated subtraction. 24 minus 8 is 16, that's once. 16 minus 8 is 8, that's twice. 8 minus 8 is 0, that's 3 times. 24 divided by 8 is 3, because we can subtract 8 from 24 3 times. In fact, that even explains our remainder system. We might have 27 divided by 6. 27 minus 6 is 21, that's once. Minus another 6 is 15, that's twice. Minus another 6 is 9, that's 3 times. Minus 6 again, that's 3, that's 4 times. We can't subtract 6 again. So 27 divided by 6 is 4, with a remainder of 3. Now before the day's out, we'll look at turning that remainder into a fraction or a decimal or whatever. But for right now, we know that much is left over after we subtract that 6 4 times. So if I were doing something like 42 divided by 3, it's not practical for me to start subtracting 3 from 42. It's going to take a lot of steps. So what I want to do is I want to come up with a way to subtract a bunch of them at once. For example, 10 times 3 is 30. If I just subtract 30, what I've done is I've subtracted the 3 10 times. Does that make sense? If I subtract the 30, I'm left with 12. I've subtracted 3 10 times. Now I can keep subtracting 3 until I get down to 0. So I subtracted 3 4 more times. That's 14. 10 plus 4 is 14. Is what 42 divided by 3 is 14. Now with that in mind, and again, I'm not trying to change the way you do division. I just want you to understand the process we're about to look at here. If I take something like 67,538 divided by 21, obviously I'm not about to start subtracting 21 from 67,000. So that would take forever. Well, not literally forever, but a long time. So just like I did up here, where I took out 10 of them at once, I'm going to try to take out big bunches of 21s. How do I know how big of a bundle to try? Well, I look at the place value here of the number I'm dividing. What's the place value of this first digit? It's in the 10,000s, right? So if I take 10,000 times 21, that's 210,000. Can I subtract that from what's there? No, 210,000 is bigger than 67,000. I can't subtract it. It's too big. So we move to the next place value, which is the thousands, to see if we can subtract a bundle of 1,000 of those 21s. So 1,000 times 21 is 21,000. Can I subtract that? Yeah, in fact, I can subtract it, what, times 3? It'd be 63,000. So now let's pause for a second and see what we did here. We subtracted 21,000 3 times. 21,000 was a bundle of 1,000 of those 21s. So we did a bundle of 1,000 3 times. So 1,000 times 3, that's 3,000 21s. We just subtracted 21 3,000 times. Or 1,000 times 3. That's where the 63,000 came from. So now we move on to the next place value, which is 100. 100 times 21 is 2,100. Can I subtract that from what's left? Yeah, it looks like I can do it twice. Times 2 would be 4,200. That's 8, 3, and 3. So what I did there, I subtracted a bundle of 100 of those 21s, and I did it twice. So 100 times 2, that's 200 more 21s. Next place value is 10. 10 times 21 is 210. Can I subtract that? Yes, I can. Looks like I can only do it once. 210, that's going to be 8, 2, and 1, so 128. So I just subtracted a bundle of 10. And now all that's left is 1s. Of course, 1 times 21 is 21. Can I subtract that from what's left? Yes, I can. It looks like 6 times, right? That'd be 126 with a remainder of 2. So I just subtracted the 21 6 more times. So what this is telling me is 67,538 divided by 21 is 3,216 with a remainder of 2, because we had 2 left down here. Now you might be looking at that thinking, that looks absolutely nothing like the long division I was taught. But it's actually exactly the long division you were taught. Let me show you how. So what we were taught to do, looking at the 21, start with the 6. Does 21 go into 6? No. So we're going to leave it blank above the 6. That's exactly what we did here with the 10,000. 10,000 times 21, that was too big. We couldn't subtract it, so we left it. We went to the next digit. Move to the next digit, the 7. Does 21 go into 67? Yeah, 3 times. The 7 is the last digit we used, so we put the 3 above the 7. 3 times 21 is 63. Subtract to get 4. If we look over here, it's the exact same thing, we just left off the zeros. So now we move to the next digit, we bring down the 5. 21 into 45 goes twice. 2 times 21 is 42. We subtract to get 3. Once again, exact same stuff. We just left off the zeros. And we'd finish it off the exact same way. So most of the processes we've been taught in math are just shortcuts. I could go back to addition and subtraction and show you how do you do addition without carrying? How do you do subtraction without borrowing? They're longer, but maybe more common sense processes behind them. At this point in this class, we don't have the time for that, but I will post videos out there from some other where I've gone through and explained those in video lectures for you. So if you want to go back and look at that, you can. It's kind of interesting to see that there's different ways to add numbers from what we were taught. Because in math, we've always been told there's one correct way to do things, and that's it. And it's not true. I can show you 3 or 4 ways to add numbers that'll work every time. 2 or 3 ways of subtracting numbers that work every time. So, our next step, we want to look at fractions a little bit here. So how do fractions fit into all of this? If I have a fraction like 3/4. A little bit of review. The top number of a fraction is called numerator. I can just hear the excitement in your voices when we hit fractions. I know fractions are everybody's favorite numbers. Actually, to be honest, if I were to ask people on their way in the door what they hated most about math, 4 out of 5 students would most likely say fractions. The other one would usually say the teacher. So the bottom number is called denominator. Now, what does it mean to be a numerator? What does it mean to numerate? Well, every 10 years, our government sends out people to do the census to enumerate the population. What are they doing? They're counting. Very good. That is a count. That is telling us that we have 3 of something. Well, denominator, we have different denominations of money, different denominations of organizations. To denominate means to classify or to give a name. So just like having 3 cows or 3 inches, this is 3/4. It's not 2 numbers, it's a single number with the 2 parts, the count and the name. So what does it mean to be a fourth? Well, let's go back to the old elementary school illustration just because it works the best. Pretend that looks like a circle. We're going to take a look at the old pie or pizza. A fourth means that pizza is cut into 4 equal pieces. Again, pretend those look equal too. When it comes to art, you're going to have to use a lot of imagination when it comes to me. So a fourth means that every whole object is broken into 4 equal pieces. Or if you want to look at it from the other direction, it takes 4 of those pieces to make a whole object. So this is 3/4, which means we have 3 of those pieces. So that's 3/4. Again, you've probably seen that illustration since about 2nd grade or so. Let's look at our operations on some of the things we want to do with that. When we add fractions, let's say I'm going to take 2/7 plus 3/7. Back in 3rd or 4th grade, when you first started to add and subtract fractions, that 3rd grade teacher told you, before you can add fractions, you must have common denominator. There you go. That's nothing new for fractions. Any number, when we go to add it, you must have the same name. So when we add or subtract, you must have the same name. In fractions, that becomes common denominator. So once you have the common denominator, how were you taught to add those fractions? Well, you do the 2 plus 3, you combine the numerators. 2 plus 3 is 5. What about the denominator?
Stays the same.
You keep the common denominator. It stays the same. Again, that's not a special rule for fractions. Anytime we add numbers, you combine the counts and you keep the same name. Same rules as for whole numbers. When you go to multiply, 2/7 times 3/7, what were you taught to do? Straight across, right? 2 times 3 is 6. 7 times 7, 49. Again, not any special rules for fractions. Just like with our 3 inches and 6 inches. We combine the counts, then we also combine the names. When we go to add, however, we can run into like 3/4 plus 1/5. If we go to add those, can we add them the way they're written? No, they have different names. So one of the first things we have to do for adding and subtracting fractions is figure out how to rename them. It is time for our break, so let's go ahead and take our break right now. And we'll come back, it's 9:21, we'll come back at 9:31 and we'll start up again.